All right, y'all, we are jumping into chapter 7, which is all about probability. So what we want to be able to do is figure out and apply the multiplication rule for counting to solve problems. So this is often referred to as the fundamental counting principle, and I promise that you've encouraged problems like this before, just maybe not in this same sort of phrase. So if we think about a Starbucks order, okay? So let's say the first decision that you have to make is, are you going to get hot or iced? Okay, so that gives us two choices for our Starbucks drink. Next thing we want to think about is, okay, do we want it to have espresso in it, or do we want tea, or what do we want? All right, so let's say that that's our decision, espresso or tea. I know there's other options. So now you had two more choices to make. So right now, the four possible drinks that you could start with are something that is hot with tea, something that is hot with espresso, something that is cold with tea, something that is cold with espresso. Okay. Next decision you have to make is, what kind of milk do you want? And I'm just going to throw a number out here. Let's say there's 6 types of milk. Okay, so now your decision has greatly increased. So now the possible coffee combinations that you have would be 2 times 2 times 6. So right now, just from the jump, you have 24 possible coffee orders. Okay, and then let's say the last decision you have to make is, what flavor do you want? And let's say that there's 10 flavors. So the possible combinations of Starbucks drinks that you could have would be 240. So you've seen these types of problems before. Very similar to something like, you have 5 shirts, 8 pairs of pants, 4 pairs of shoes. And how many ways can you create outfits for a vacation? Something like that. So you've encountered these problems before, just maybe never heard of it as the fundamental counting principle. So using the multiplication rule for counting, it says every card in a standard deck of cards has 2 identifying characteristics. A suit, so that could be clubs, diamonds, hearts, or spades, and a rank, and that would be ace through king. Each possible pair of suit and rank appears exactly once in the deck. How many cards are in the standard deck? So if we think about this, you have 4 choices of suits. Okay. And then as far as rank goes, let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So you have 13 possible ranks, and that means a standard deck of cards should have 52 cards, which, as we know, is true. Okay, but that's where that fundamental counting principle comes into play. We had the 4 choices for the suit, 13 choices for the rank, multiply them together, and we end up with 52. So similar to what I kind of referenced a minute ago, 4 pairs of shoes, 8 hats, and 5 belts. And how many ways can Katie pack a shoe, hat, belt outfit? So 4 choices for her shoes, 8 choices for her hats, and 5 choices for her belts. So 4 times 8 times 5, that's 160 possible combinations. All right, so take a second if you want to pause the video and consider this problem. So it says the IT coordinator is making everyone create new passwords. It must consist of 3 non-repeating letters and 2 non-repeating digits. How many passwords can be created? Okay, so if we think about when it says non-repeating, that means that your password can't be like AAA22. You have to switch it up, so if you decide to use the letter A, you can't use it again. So if we're setting up our password, there's going to be 5 blanks here because we have 3 letters and 2 digits. Okay. So we set up our 5 blanks. Now the first part of your password is 3 non-repeating letters. So the alphabet has 26 letters. So you have 26 choices for the first one. Then 25 choices for your second letter that you're going to use, because now you've used whatever letter, you can't use it again. And then you have 24 choices for the next. Okay, so now we've satisfied our 3 letters. When we talk about digits, okay, your password could end in like 1, 2 or 3, 5 or something like that. But when we talk about a singular digit, you only have 10 options for what that singular digit could be. It'd be the numbers 0 through 9. So you have 10 choices here, and then 9 choices for your second digit. And then we could multiply that together, and that would tell us how many possible passwords we could create. So let's see what that looks like. So the possible password combinations that you have is 1,404,000. So just from that little setup, possible of 1,404,000 passwords. And your homework assignment tonight is to write all of those possibilities down. No kidding. All right, and so that is it really for what the fundamental counting principle is. Basically, you're going to take the total number of possibilities for each thing that you're asking. How many hats, how many belts, how many pants, whatever. And then you're multiplying all those possibilities together to get the outcome. All right, I will see you for the next section.